I'm John Lundgren. I live over in South Dakota, north of Brookings a little ways, north of Sioux Falls by an hour. I'm a farmer, I'm a beekeeper, and we do a little bit of science on the fate of agriculture and humanity. So we're going to talk a little bit about that. This is a weird presentation. It's one of the few bee talks that you'll see that doesn't have a whole lot of bees in it. But this is the answer to the bee problem. All right. Um, yeah. I was working down in Florida with some farmers down there. I was talking, a lot of people, yeah. When in Florida, I mean, the oranges are the identity of the state, right? I mean, it's on the license plate, everything. And we've been doing some projects down there in recent years. So what most people don't know is that actually Florida citrus is basically dead. Florida agriculture, in a lot of ways, is almost dead. Um, their citrus is at about 4% of the production that it was 20 years ago. They're blaming it on the disease, uh, HLB. But if they really want to get to the root of the problem, they're going to have to look a little closer in the mirror. They started with good soil, forest soil in Florida. And on that picture on the right, you see that they turned it into beach sand through their agricultural practices. And the trees that are remaining, many of them have an antibiotic, a can of antibiotics shoved into the stem to keep the tree alive. I was talking with one of our conventional producers and listening to him and kind of asked him what he thought some of the issues were that they were facing. And he said, John, the roots on our trees, they're anemic. They're not growing the way that they used to. And I explained to him that we're watching a number of citrus groves come back to life. And one of the tricks that the farmers are using is that they're planting vegetation from trunk to trunk. And he heard that and he's like, John, if that is true, then that flies in the face of everything that we're being told by the Citrus Board and by the universities. And I asked him, how's all that advice working? And he thought about it for a minute and he said, yeah, you're right. They're not looking out for us anymore. We're seeing things around the country at this point, right? Things that haven't been seen in 100 years. This photograph isn't from the 1930s. This is a photograph from down the street from my house 2 years ago. A dust storm that wiped the hometown of Christy Nome off of the map, Castlewood, South Dakota. Yeah. And the next day they were out tilling again. How's your bees doing? My bees all died last year. Um, and we've sunk hundreds of millions of dollars into the bee problem at this point. And I had to ask myself as a scientist, how's it working? Doesn't seem like we're going to win this battle by treating it as a bee problem. Okay. And bees are just the tip of the iceberg. What we're seeing is declines in biodiversity on Earth, the likes of which the planet has never experienced a catastrophic mass extinction event to this magnitude before. This is worse than when the dinosaurs were killed, right? Or were driven extinct. Back in 2022, we were seeing these issues that farmers were facing, that beekeepers were facing, and we started to, one of our farmer friends pointed out that the deer in her community were starting to express problems. that were starting to show issues. 70% had these jaw deformities. 70% of the males had genital deformities. And she wanted to know whether or not neonicotinoid insecticides might have something to do with it. And so one of our graduate students, this was in conjunction with South Dakota State University, and Elise started a master's program, the likes of which will never be repeated again. This experiment was extremely difficult to run. She administered imidacloprid to captive deer. She fed it to them in their water at different doses, and then monitored the deer's health over 2 generations. We looked at a number of different tissues: blood, milk, brains, livers, spleens. Spleens seem to be the magic organ in this one. When we quantified the amount of imidacloprid found within the deer spleen, it tended to correlate well with fitness responses in the deer. And so what we see in those fawns is that the dead deer had substantially more imidacloprid in their spleens. And when we dug a little bit deeper, we found that the more imidacloprid that we would find within the spleens of these deer were correlated with reduced body weight in the fawns, reduced organ weights in the fawns. Their thyroid hormone levels were messed up. Anybody in your family have hyperthyroidism, hypothyroidism? 2 of the members of our staff had that. Jawbone lengths were disrupted. And then the activity levels, they were lethargic. Those deer that received more imidacloprid and had it in their spleens had greater levels of lethargy. What's a slow deer in the wild, right? Yeah, dead deer. So critics would say or argue appropriately. They would argue that's what you force-fed those deer imidacloprid, John. Of course you're going to see fitness effects. This is what we were able to experimentally generate under controlled conditions. Hunters in North Dakota went out and harvested deer, and then they sent us the spleens. Under wild conditions, this is what the native population had: 3 times the level of imidacloprid than what we were able to generate under controlled conditions. Unreal. And then those same hunters, actually, this is North Dakota, not Minnesota, sent us predators' spleens. And this is now published. It's quickly rising in the ranks of studies in terms of its social media impact. Looked at fishers, bobcats, and river otters, and found that these top apex predators were also contaminated. How on earth is that happening, right? The imidacloprid's getting into the water. It's getting into plants and animals that have never consumed a treated corn seed in their lives, right? We started to ask farmers that were a part of the 1,000 Farms Initiative, which I'll talk about in a moment. We started asking croppers, have you experienced any health problems? Have you, any of these autoimmune diseases, any mental health issues? A quarter of them self-diagnosed as having depression. A third of them anxiety. Now we looked at not just the croppers. This is corn, beans, wheat, that kind of stuff, right? And then we looked at the national averages for all of society. And we find that we have 3 times the depression rate in our croppers. We have twice the asthma rate. And then I asked those croppers about Parkinson's and cancer in their families. We're killing our farmers. We're killing our farmers, literally killing them for corporate greed. And I used to think this was just a bee problem. I used to think that, just reducing it, maybe by a spray, gosh, that's going to move the needle. That'll think of the active ingredients that we'll remove from the environment. That isn't good enough anymore. I was giving a talk in Napa. This was the richest farmland on earth. Um, and they had this late $1 million an acre for mature land for mature vines out there. And this lady got up and she gave a talk and she explained that she was doing an experiment on her farm. This is great. We want to see that, right? And she compared for ground cover management, grazing, and by sheep, mowing, and then Roundup herbicides. And she explained to the crowd that all of them were about equally effective and at controlling the vegetation, but the Roundup was so much cheaper, and therefore they should use the Roundup. And then they gave the mic to me. Let's walk this one down the chessboard, huh? Few moves. You're at the end of your life, and you have to look your spouse in the eye, and you have to say, I'm sorry. I thought I was saving money. I thought that money was what was important in this case, and I was told about the risks, but I didn't believe it. I couldn't see that. And now our grandkids are real, real sick. And I'm sorry. Does that cut it? Does that cut it anymore? I don't think it does. Meanwhile, amidst all of this, we were starting to meet farmers that were growing crops, livestock, without the need of a lot of agrochemicals. They were what it was called was, maybe some of them didn't know it at the time, but this is now what's being defined as regenerative agriculture. And if what they were saying, a lot of times they were describing these stories that defied what science said was possible. And if what they were saying was true, then there was tremendous global financial investment and food policies that were ready to get behind this. But the question that they all had was, is this real? Is this scalable? Is this transferable? Is this just something that some wacko farmer is talking about right now? We thought that science might be able to help fill this. And so as a team on our farm in the middle of nowhere, South Dakota, we started asking questions about what a research experiment might look like that could kind of rapidly fill this gaping chasm in terms of what the farmers were saying was possible and whether or not that was something that the world could get behind. The answer was that it had to be big. An experiment to test this idea had to be very big. It had to simultaneously address all food systems, all ecoregions of North America. It had to measure simultaneously multiple regenerative outcomes. It had to use farmer-derived best management practices, not something some academic came up with in behind their desk in a laboratory. And then we had to ask the question of who could do it. And we ain't the prettiest, and we ain't the smartest, and we sure as hell ain't the richest. But for some reason, Ecdysis Foundation attracts people that want to do something, that really want to make a difference. And so I took kind of a ragtag group of people from all over the planet and I turned them into scientists. Over the last 4 years, 2026 is number five, we've visited 1,700 farms across North America doing full systems measurements, 38 states, 2 Canadian provinces. Home base, headquarters for Ecdysis is the Blue Triangle in eastern South Dakota there. 35 plus cropping systems, 10 plus livestock systems. It was, yeah, this is, yep. You see a couple of areas of the country that we haven't been to yet. Yeah, 2026 is upon us, and we're going to try to fill that one in. Each of those dots is a farm, okay? And they fall along a continuum from industrial, conventional to wacko regenerative, all right? And we can score those. In about 2 minutes, I can ask 8 yes or no questions to a farmer and put them along that continuum and make pretty accurate predictions as far as what we might see in terms of soil organic matter and how many pollinators they have on their farm and how fast the water goes into the soil and how happy they are and whether they have Parkinson's in their family. It's extremely accurate. It's a very, yeah, I mean, yeah. And it works. We have a different set for livestock systems. In regenerative ranching, what you want to see is animals kept tight, move frequently, and that pasture allowed to rest. And that rest is really important for the plant community to research. And then on each of those dots, we started measuring things. Because regenerative agriculture isn't just about soil carbon, right? It's about many, many outcomes. It's about using our food system to capture and store carbon. It's about restoring water cycles. It's about increasing the nutrition of food, increasing farmer wellness, profitability, and reducing pollution. And right in the center of that whole thing is biodiversity. I was talking with a farmer friend. He was Amish up in New York, and we were sitting in his field. And I was explaining all of the things that we were about to measure on his place. I said, "Yep, we're gonna get like 500 different data types, right, from this farm. It's a pretty extensive study. We're going to tell you about all of the carbon levels in the soil's chemical and physical structure, all the way down to 60 centimeters." And he's like, "Okay." And then we're going to tell you about water and what it's doing out there. He's like, "Yeah." And then I'm going to name all of the microbial species in your soil, like all the bacteria and fungi. I'm like, "Yeah." And all of the insects and all of the plants and all of the birds. And his eyes got wider. And I asked him afterwards, why did that resonate? Why did that biodiversity resonate? And he explained that of all of the scientists, as part of their faith, they're meant to be stewards of life on Earth. Farmers are, beekeepers are, humans are. And of all of the scientific teams that were coming out to measure their farm, nobody was telling them about that biodiversity. Now I understand after 4 years that all of those other outcomes in the periphery on that slide are artifacts. Those are outcomes of growing life on farms, increasing biodiversity on farms in all of its forms. This is from 200 plus rangelands across North America. What we see here is in the center, that bullseye is the conventional ranching operations. And then the black dots are the percent increase in each of these categories of life on the most regenerative operations. So what you see is that birds, insects, fungi, arbuscular mycorrhizal fungi, bacteria, plants, you name it. All of these increase significantly with the number of regenerative practices. And I could show a similar slide for croplands. I mean, when you're an ecologist, one of the, yeah, I mean, to see consilience in so many different forms of data or types of data, different organismal groups to all behave the same way, boy, that gives a lot of confidence in the results. That life does things. One of my master's students, this was by Tia Buzenitz, Katya Buzenitz, she did a study on these rangelands to see how increasing regenerative practices contributes to honeybee health. What she found is that as you increase the cattle's density, graze it for a flash, allow it to rest, and then yep, don't allow animals back on that for a while. What ends up happening is that instead of reducing and suppressing plant growth, what that does is stimulate it. And so she found that floral abundance and species richness were significantly increased on those regenerative rangelands compared to their conventional counterparts. So that regenerative grazing practices ends up promoting floral abundance. The more biomass in these plant communities was associated with increased brood production and reduced varroa mites. When people tell you that varroa mites are what's killing the bees, I don't think that they understand the system very well. A pest is never, ever the problem. It is always a symptom. And what this data suggests is that when you have a pest like varroa mite in your honeybee hives, it's because it's in an unhealthy habitat. In the end, over the last 4 years, we have generated one of the largest bioinventories of life ever created. It's ranked about number 3 in all time, I think, behind La Selva down in Costa Rica, and then the Smoky Mountains did a really comprehensive BioBlitz for a number of years. Those ones took about 20 years. We did ours in about 4. We've identified about 15,000 species from our food system. And we're adopting artificial intelligence for image recognition to identify all of the invertebrates and for sound recognition so that we don't have to have an ornithologist deployed to every single field. We have a program now that's trained to take a sound file, rip out the biological noise, and isolate the bird songs, identify and annotate them so that we can actually get some pretty accurate counts on birds as a result of that, or perceptions of bird diversity as a result of that. And then we're also looking at eDNA associated with microbial species so that we can actually identify those taxa. What does this do? What does this do? All of this life is good. Yeah, it helps promote honeybees, but honeybees are a part of that life, aren't they? Well, one of the first things is that it helps our food system become a tool for combating climate chaos. Um, this is from croplands, row crops, so corn, beans, wheat, that kind of stuff. This is total carbon in the soil column. Imagine that those two bars are each a soil core. What I want you to take away from this graph is number one, the probe on the right, the bar on the right with the regenerative is significantly greater. That means there's more carbon in the soil that's being taken from the atmosphere and put back down into the ground where it belongs. The other thing that I'd point out about this slide is that science says that carbon accrual really only happens in the top 3 sections, the very shallowest soil depths. That's because that's where most of the life is in that soil. But what this data says is that regenerative cropping systems are actually changing the carbon levels all the way down the soil profile. at depth. And if we were to go deeper, I have a feeling we'd find even more carbon down there in the regenerative ones. That changes the way that we think about ecosystem functions. And it suggests that if we were to convert all of the croplands in North America over to fully regenerative practices, it could offset about 2 years worth of annual emissions in the US. If you were to convert all of the rangelands over to regenerative practices, it could contribute almost 5 years of annual emissions. What could we do with 7 years worth of annual emissions taken out? When you look at the next best strategy, the enhanced rock weathering, I don't know, taking and piping carbon dioxide across the country and shooting it into the ground, the results or the capacity of those technologies are laughable compared to what our food system can do, while growing more life, while increasing the resilience of the rural economies, so on and so forth. We went to Washington State, Eastern Washington, and then also Manitoba, Saskatchewan, and North Dakota. And we looked at some farms, cash grain producers, that were transitioning over 3 years their land to fully regenerative practices. What we found is that those farms, at the end of that transition period, 90% of them had eliminated all insecticides and fungicides from their operations. 2/3 of them had eliminated all herbicides and all synthetic fertilizers. If those farmers were to go down to the co-op and ask them, what should I be doing on my field? Do you think they'd get that answer? Hell no. They'd be given another jug, wouldn't they? Why should beekeepers care about synthetic fertilizers, fungicides, and things like that? Those aren't insecticides, right? They don't kill bugs. One of my master's students, Stan Pachenka, just finished his thesis, and he looked at different regenerative practices to see which ones were most influential against insects communities within wheat. Bottom line from this graph is that if you want to kill insects, spray in insecticides. If you really want to kill insects, use a chemical fertilizer or an herbicide. They're probably more damaging to insect life than an insecticide is. That's not the way that was supposed to work, was it? We've been working in almonds for, geez Louise, almost 10 years now. I'll bet 8 years. It's a long time. Working with regenerative farmers out there who are kind of changing our perceptions. They're turning the spigots off in California almonds, in case you didn't know about that. Sigma, the Central Valley of California used to be a wetland, and they turned it into a desert through agricultural practices. But we asked regenerative producers, what they were doing, and learned that their water infiltration was 22 times greater than in the conventional orchards. And the regenerative orchards were reducing water use by 30–70% without sacrificing yields. Seems like an awfully good solution, doesn't it? We've been partnering with the Periodic Table of Food Initiative, which is run by the American Heart Association, as well as Ecdysis, which is a nutritional company that's doing some analysis. And they're giving us extremely comprehensive, it's probably one of the biggest or most comprehensive examinations of food chemistry ever conducted. 16,000 phytonutrients or something like that from these yield samples. And what we're finding is that the wheat in regenerative agriculture, this is the tip of the iceberg, folks. I just haven't analyzed all the data yet. Wheat has twice the protein and significant increases in half of the micronutrients, these ions that we measured as associated with this study. So yeah, that's pretty valuable. More nutritious food. because the nutrition of the pollen and the nectar that are coming off of these crops is also going to be affected. And that affects your bees, doesn't it? Okay, can these farmers feed the world? Well, we start by looking at just the yields of these cash grain systems. That's the systems that we started this whole project on, and find that corn, wheat, soybean yields, they equal the national averages in these regenerative systems. Okay. This was a study, though, of best management practices. We weren't just cherry picking the best regenerative and some crappy conventional ones. The conventionals had higher yields. But the issue was that they've spent a lot more to get those yields, such that the net profitability ends up going or being equivalent within these two systems. And depending on which of them you're looking at, that net profitability can actually be greater within the regenerative systems. So is it real? Does regenerative agriculture actually deliver on these promises that it makes? Or is this just some panacea that farmers have created? Yeah, yeah, it is. I think it's real. Our data would suggest that it delivers on these promises, all right? And via biodiversity promotion. But it's different than what I thought. When I got into this, I thought this would just be like a series of practices, right? And that was what was going to be the important drivers. Now I understand that it's a lot more complicated than that. That we have to, what we're asking a lot of these farmers. And I also didn't know that, I mean, when I got into this experiment, I thought that data was going to be the most important outcome. That was the output, right? We're going to generate a lot of data, and that data is important. But I didn't understand that my job as a scientist was also just to help to make these farmers feel seen, I guess. Dell and Marie, they're wild blueberry growers up in Maine. They're in their 80s, and they've been working their entire lives, sticking their necks out, working hard, fighting against the swell of industrialization that was going to wipe out their community. And here they are at the end of their lives, and they just want to know that it mattered, that somebody cares, that it's not just going to be forgotten. And in drives this team of in three crappy minivans, and it spills out this group of scientists that think that this is the coolest farm that they've ever seen, and they capture it. And I didn't understand that it was my job as a scientist just to make these farmers feel heard, that was a part of my job. There's a connection there. And there's a lot of global food policies or advice about bees that are being generated by data that doesn't have that connection. I wish as a younger man, as a young scientist, that I had been a lot smarter. Because I know now that when measuring the beauty and the wonder of the natural world, the most important tool that a scientist has is their heart. This is what I think of regenerative agriculture needs to be defined as now. And each of these sentences could be unpacked in its own talk, right? Regenerative farmers farm smaller and better, not bigger and simpler. That doesn't mean they have to farm small. That means that they have to change their metric of success. They have to change that identity. Boy, that's hard, isn't it? Without support, they have to be changing the metrics of success. They have to be changing, what it means to be a good farmer. often in the face of their community and their families, that telling them that they're stupid and that this is the dumbest thing they've ever heard. And for some, mavericks, that's really easy, but for a lot of farmers, that's really challenging, and they need that support network. Boy, inherent in the beekeeping community is a great support network. Human feet touch every acre of a regenerative farm's soil. They're growing food, not commodities, for their communities and their families. But most of all, regenerative agriculture celebrates life. Fundamentally celebrates life. Yeah, well, I think I'll stop there actually. Um, every year I start with $0. I have to raise 4 million, and by the end of the year I give it all away. It's a crazy world. I don't know why this is happening or how this is working, but it is. Um, please help. We need your help. Um, and if you know any farmers that would like or benefit from being a part of this study or need their story told, please have them reach out. There's a little QR code, and they can, yeah, they can kind of scan that or reach out on our website. That'd be fine too. That's all I got.
All right. Well, I'm just opening the chat. Uh, let's see. They've moved all the settings around. And we're asking people to throw their questions into the chat for you, Jonathan. But I do have one that I'd like to start with, if you don't mind.
Sure.
Can you talk a little bit about conversations or your experience with farmers, and do you feel like they're aware? Well, of course they're aware, but uh, do they feel trapped with pesticides, and are they realizing the effects of them on their physical health?
I think the elephant in the room is that, yeah, they know it. I mean, driving around the country, the most miserable farmers that I met were cash grain growers. There is no scenario in which these cash grain growers get ahead, right? They are trapped. If their metrics of success were taking over that next quarter and are getting the biggest grain bins, getting the biggest trucks, and grandpa and dad were real good at that, and now they're stuck and they've got thousands of acres and they're trying to figure out how on earth what they can grow there in order to make this work, because they don't want to lose the family farm, right? Their legacy is wrapped up in this and their identity is. But they're borrowing $850,000 a year to make $50,000 a year. And they stopped asking where that other 800K went. Every time they get a bumper crop, the chemical companies, the seed companies, the tractor companies are all poised to squeeze every last drop of money and profit out of them, so that they're given just enough to inch by and serve as a patsy for these corporations to get government money. That's their whole business model.
John, I don't think you mentioned in the beginning, but do you uh, do you want to share a little bit about your history and how you came to be motivated on this work?
Yeah, I mean, I was a USDA scientist for a long time. And but I could, and I had accolades here, there, and everywhere, right? I mean, I was doing the system right. I was playing the game. Tons of papers. I had all kinds of grants and grad students through the puppy mill, serving on federal advisory boards with the EPA, grant panels, things like this. I was doing it, right? But I could drive from South Dakota, where I lived, over to where my parents lived. And despite all of my science that was supposed to be helping people, things aren't getting better. It wasn't getting any better. And so it really forced me to ask that question, how is it working? And whether or not there was a better way to do science that could actually get to the root of the problem. And that's when I quit and bought the farm, literally.
Best thing you did, right?
Scary, pretty damn scary. Terrible risk.
Do you think a lot of regenerative farmers are having trouble getting loans and startup money?
I don't think banks understand it very well. Getting land access is a huge problem at large, right? I mean, the big are getting bigger and the small have a real struggle to get in. Blue Dash is only 53 acres. And it was always meant to be a demonstration. That's my farm, by the way. It was always meant to be a demonstration of how can you make a living off of 50 acres or less, because you ain't going to be supporting, yeah, you ain't going to be buying 1,000 acres at 15K an acre or something like this, 25, 30,000 an acre. So land access is one of those central issues, I think.
Do you think transitioning to regenerative farming is a sort of a one farm at a time uh, process? There isn't any way to do this on a larger scale, is there?
Yeah, there is. For sure there is. We can scale this. It is scaling. Farmers, I mean, regenerative ag within the 1,000 farms, it's not. I mean, we're focusing our study design on farms that, the range of which fit the averages for that particular ecoregion and food system. So we're not looking for like the little dinky, mom and pop things, unless that's representative of the food system. So for vegetable production, for example, you're going to have 10 acres or less. For cash grain systems, you're probably going to have, 100 acres or something like that for a field size, or 40 acres for a field size. For rangelands, it might be 300 acres. It might be 22,000 acres.
Um, we clearly have some farmers online with us, so some of these questions are coming from them. But how do we get the necessary resources available for farmers that reflect the benefits of regenerative ag? Is it a policy problem or a corporation issue, or what do you think?
As soon as I think a lot of this is changing the culture of food production. We've got to be growing things for local and regional markets, right? I think this is step one. The industrialization, globalization of food doesn't work. I mean, look at the honey industry, for crying out loud. I mean, that's completely collapsed because of globalization. Um, I was in Puerto Rico a couple of weeks ago, um, working with farmers there, and they had these farms on the hillsides in the tropical rainforest. I mean, the hillsides were like super steep. It was a pain in the ass to sample, but we were out there, and they were growing bananas and coffee and citrus and plantains and breadfruit and things like this. They called them survival farms. Every one of those farmers could tell their lives in two phases: before Hurricane Maria and after Hurricane Maria. And they had been convinced to rely on the mainland for food. And then the hurricane hit, and nobody came to help them. And now they're growing food for their communities again. And I thought while I was there, I'm like, I'm looking into a damn crystal ball, right? This is, I mean, we think of island biogeography and how speciation happens on islands at a different rate because based on the distance and the size of the landmass and distance to nearest neighbor. The same concepts apply to our food system and resilience thereof. And I'm watching this thing in Puerto Rico, and I'm like, I'm watching this on the mainland in slow motion, but the end is going to be the same.
John, with all your, you've had experience with pesticides from all angles. Do you see any end to it? Just using neonics as an example, do you see an end to it?
Yeah, I think we need to understand that there's a better way. You don't need these. And it doesn't have to be ideological. It can just be a business decision. Why on earth would I buy something I don't need? And that needs to be I mean, banning things is tricky business, okay? And that's what the pesticide companies want you to chase, right? They're dangling these toxic things, and we're all like, oh, yeah, we're almost there. We're almost to the finish line. We've almost got that sucker banned. They've got 5, 10 more of them sitting in the wings here, folks, that may be even worse than the one that you just got banned. Yeah, we need regulation. I don't see it coming down the pike anytime soon. It's just getting worse. So let's change the system because the corporations that are killing our farmers and our beekeeping industry don't have an answer for that one.